talking about areas of a triangle today. You guys remember how we find the area of a triangle?
Base times height divided by 2.
Base times height divided by 2. So the height would be the line that's vertical to the base, goes up to the vertex, so it would be like base times height divided by 2. But what if you don't know the height, but you know the size of the triangle? Actually, alright, we'll call this side A, we'll call this angle C. Okay, so for this one to work, actually, did they switch those around? No. For this to work, you need a side, an angle, and a side, like side, angle, side. So the angle can't be over here. It's got to be between the two sides. Okay, so if we don't know the height, that's the problem. How can we figure this out? But we know like A and B and angle C. Well, let's see. Let's say C was like. I'll put some numbers in here. Let's say C was like 40 degrees, and side A was like 12. Okay, how could we find side H?
We use sine.
Right. Relative to this angle, the height would be the opposite side of this little triangle that was created when I drew it in. And it's a 90-degree triangle, right? Because it's perpendicular. So opposite over hypotenuse is sine. So sine of 40 equals opposite of hypotenuse. Hypotenuse is 12. So if we just do 12 times sine of 40, that would give us whatever the height is. Okay, so we just do this, 12 times sine of 40. That gives us the height, and if we do that times the base and divide by 2, that would be the area. So basically the height is like A sine of C. And the base is a B. I'm going to throw that in. And you have to divide by 2 or multiply by half. So this is an area formula for any triangle if you know two sides and the angle in between them. 1/2 AB sine of C. It's pretty easy. AB stands for the two sides, and C is the angle between. Does that kind of make sense?
Yeah.
If you don't understand exactly how I got the formula, it doesn't matter. All you have to know is how to use it.
Are we going to use that on all the problems?
Pretty much. That's what this assignment's about. I mean, of course they're going to throw in a couple curveballs, but
Sweet.
like 19 and 20. All right. I forgot to shrink the scale.
Mine said syntax error
For what?
for the first one.
Okay. Number 1, throughout the exercise, give areas in radical form or 3 significant digits. Give links to 3 significant digits and angle measurements to nearest tenth of a degree. In exercise 1 through 4, find the area of triangle ABC. All right, they did not draw it for us. We don't really need it drawn. This is kind of just plug stuff in. But for the A question, A is 4, B is 5, and the angle C is 30. So we're just going to do 1/2 side times sine of 30. 1/2 AB sine of C. 1/2 times 4 times 5. Actually, that's 1A.
I got 5.
Yeah, it should be 5. For B, what did they change on B?
1, 1, 2.
150.
I still got 5.
Yeah. Now, yeah. Because 30 and 150 are reference angles, they're going to give the same ratio, like spit out the same thing. That's why I think they're trying to get you to see that the reference angles give you the same value. Same thing with 3. I think, is that the same on all these? Yeah. Okay, so number 3, they use different letters, but angle B would have to be between sides A and C, so it's still the same formula. So it's 1/2 times 6 times 2 times sine of, what was it, 45? Yeah. Sine of 45 is square root of 2 over 2 times 6. So this should come out as 3 square root of 2. Right? Yeah. Does your calculator spit out a square root on that one?
Mm-hmm.
Okay, well, B, because 135 is the same reference angle as 45, it should spit out the same. These two are actually going to give you the same thing. So it's going to be 3 square root of 2. I think I did that on all of them. 1 through 4. Okay. Okay, number 5 is kind of weird. What does the formula K equals 1/2 AB sine of C become when C is a 90-degree angle?
90.
What's sine of 90? It's going to be 1. So, if the angle is 90 degrees, it's going to be 1. So the formula, multiplying by 1 doesn't really do anything, right? So the formula just becomes 1/2 AB. Why would the formula just be that? Okay, because if your angle is 90 degrees, you can just use the 2 sides of the triangle as your base and height. So it's just base times height divided by 2. You guys get what they're trying to show you here? So they wanted you, if it's a 90-degree angle, the 2 sides of the triangle can be used as the base and the height. So that's why the formula is basically just side times side divided by 2. They wanted this thing and they wanted the picture that I drew. Oh, number 6. Is showing the diagram the right angle C is triangle ABC is obtuse. Gives the area K of ABC. Yeah, 6 is weird too. I better look at that. So on an obtuse triangle, you might have to draw the height outside of the triangle. I'm just drawing what they drew on number 6. Okay, angle C is obtuse. Show that 1/2 AB sine of C gives the area of the triangle. Let's see. So all right, so what does sine of C give us? What does this part tell us? What ratio would sine of C give us?
The height? Was it?
Opposite over
Hypotenuse.
hypotenuse. So it turns into H over A. Okay, and then what's gonna happen? How will this simplify? What's A times H over A?
HA over A squared?
H over A times A is
H.
H, so these two just cancel out. So it just turns into 1/2 base times height. So this is kind of how you show it. Which is the area of a triangle, right? Yeah, that was weird. Okay, number 7. Not as weird. Find the area of triangle XYZ. Okay, 16, 25. Alright, if 16 is side X and side Y is 25, side Z is unknown, but this would have to be angle Z between them. Okay, so they just gave us kind of the basics here. 52. So just plug it in. What's the formula? 1/2 times side times side.
158.
Times sine of 52. 1/2 times side times side times sine of the angle in between. Yes, this is what I'm thinking. Alright. Numero 9. Okay. So on 9, they're giving us the area, and they want us to find angle C, the missing angle. So how could we do that? So the sides are 12, 5. Doesn't really matter what the picture looks like. But they told us that the area is 15. So how can we find angle C?
It's like algebra.
Yeah.
Did you use this? Oh,
No, don't East Coast line. Set up an equation just like this, but there's going to be a variable. So, what would the equation be?
1/2 times 5 times 12 times sine x equals 15.
So we're missing sine of C, but we do know it's supposed to equal 15. Now, how can I work backwards to figure out what angle C is?
15
Okay, 15 divided by this stuff. Let's go ahead and simplify this. What's 1/2 times 12?
6.
Times 5?
30.
30. So really we can just divide by 30. 15 divided by 30. 1/2 or 0.5. Now what?
Inverse.
Sine, yeah, sine inverse of the ratio should give you
30.
the angle 30 degrees. Really? Yeah, it is. Okay. However, and this is what they were trying to point out on number 1 through 4. There's another angle that could actually give you this same ratio.
150.
Yeah. Where else does sine equal something positive? Over here. So 180 minus 30, which is 150, should also give you that same answer. So there's 2 answers. And number 10 is like this, somewhere. Alright, 19. This is the best. Let me draw it first. Don't you worry.
No, we're not doing 11.
Oh, yeah, I forgot about 11 and 12. Find the area of the regular octagon. Oh, yeah, we'll do that one. Okay. What's an octagon?
8 sides.
Wait.
Yeah, don't really need a picture, but I'll go ahead and do it. Just to show off my octagon drawing skills. Find the area of a regular octagon. What's regular mean?
Equal sides.
All the sides are the same, angles are the same.
Equilateral.
It's in a circle with a radius of 40, so I'm not going to draw the circle, but the radius just means it would go to the corner. And they want us to find the area of this octagon. Mysteries. Any ideas?
No, wasn't there a formula for it?
There was in geometry, yes. What we're about to do kind of simplifies to the formula we learned in geometry. What's this?
Triangle.
Just a pie.
One radius.
How long is it?
For the same.
Okay. How about this?
The math thing is.
The sine.
360 divided by 8.
360 divided by 8. How do you get that?
45.
The full rotation is split into 8 triangles. Since this is it, they're all equal because it's a regular octagon. So 360 divided by 8, if you just divide that circle into 8, should give you 1. Okay. So the area of this triangle, just this part in here, would be 1/2 times side times sine of the angle.
565. Or wait, no, 566.
Just say to round. Okay, there should be a square root involved in this. Sine of 45 is like square root 2 over 2, I think. I think it's like 400 square root 2, isn't it? Yeah.
Yeah, I got 565.7.
Yeah, I guess your calculators failed you. This right here is square root 2 over 2. So I guess, I don't know if they said we had to use the square root answer, so maybe it'd be okay if you had the decimal. I don't know why your calculator spit some things out. I guess, I don't know. Anyways, that would be the area of one of these triangles. So how do we find the area of the entire octagon?
Multiply by 8.
Times 8, yeah. So 4 times 8 is 32, so this would be 3200 square root 2. Let's say what measurement we're using. Centimeters. Yeah, the formula now this formula wouldn't be very helpful from the information they gave us, but the formula we learned in geometry was 1/2 apothem perimeter. The apothem is like this thing. Now they didn't give us the apothem, so we'd have to find it out. That'd be a lot of work. They didn't give us a side, so we couldn't find the perimeter very easy. It'd been a lot of work to use that formula. But yeah, I'm pretty sure these two are related. out again. 8, 6, 9, 11. And, okay, we're just supposed to find the area of this irregular polygon. Any bright ideas? Well, you probably just have to play around with it for a while to kind of figure it out. Remember when we like find the area of some like odd shape like this? How do we do that? Right, you like cut it off somehow and then find the area of the two rectangles and add them together. Okay, that's kind of the idea here. If you split this quadrilateral, you get two triangles. So if we can find the area of the two triangles and add them together, that's the plan. So I split it in a way such that one triangle has a 90-degree angle because that makes this triangle easy and it'll help us figure out this triangle. So how do I find the area of that triangle? This one.
1/2 times 8 times 6.
Yeah. 1/2 base times height. Since it's a right triangle, we can just use 6 and 8 for the base and height. 3 times 8, 24. So this triangle is 24 square units. So all we have to do is find the area of the other triangle. How could we find the area of the other triangle? Well, we need like a side, and an angle. No. Well, okay. If we use Pythagorean theorem, we can find this side, right?
Yeah.
6 squared plus 8 squared equals what squared? Yeah. It's 10. Okay, so we have a side. Do we have an angle yet? No. 115 goes all the way from there to there. And I just need this angle right here. So how can I find just that angle?
Did you have it?
No. If I find this little angle right here, because I have a triangle that I have enough info to find angles in, right? A right triangle. If I know this little angle, then I can do 115 minus this angle, and that gives me that angle. Okay, so how could I find this angle? Well, this is what we did yesterday, remember? Right, tan inverse. Because we have the opposite and the adjacent. So
53.
if I call the little angle x, tangent of x should equal opposite over adjacent. So we need tan inverse of 8/6 or 4/3 or whatever.
53.13.
Okay, let's just call it 53.1. Right there. Which means the angle on the other side would be 115 minus 53.1.
61.8.
And we've got enough info. We've got our side angle side, so we can use our new area formula to find this triangle. So it's 1/2 times side times sine of the angle in between. Morning sunshine.
Wake up. Ooh.
That's gonna make a tower on your head.
48.47.
Huh? Oh, 48.4. Okay, we'll call it 48.5. So, that's the area of this triangle. So you add these two triangles together, and you get your total area. What is that, 72.5? Let's see, is that what they got? Okay, they rounded it to 73. So, yeah. They're kind of vague on what place to round these to. Oh, it does say the nearest unit. So, 73 units squared. It does say round to the nearest unit, which means the ones place. Alright. Now today is Wednesday, I guess, so if you have to turn in on Friday, you can.